In our last lesson on vectors, we are going to talk about how to find the cross product of two vectors in three-dimensional space. Be sure you set up your paper in Cornell format and include the title in your notes. Okay, a skill you will need is how to find the determinant of a 2x2 matrix. Okay, and a matrix is just a way of organizing numbers. When we find the determinant of a 2x2, that just means 2 rows, 2 columns. We're going to basically be cross multiplying. So you'll notice in our matrix A, B, C, D, we're going to multiply A times D and B times C, and then we're going to subtract. Okay, so it is subtraction to find the determinant. So the example that's given, we would do 5 times 4, which is 20. Okay, 8 times negative 1, which gives us negative 8, but if I'm subtracting a negative 8, then 20 plus 8 would be 28 for the value of the determinant. When we're finding a cross product, what we're actually finding is a vector that is orthogonal or perpendicular to two given vectors. And again, remember, we're only working with three-dimensional vectors to find cross products. Okay, and we will model this in class tomorrow. Okay, but basically we have two vectors given, and we're going to find a vector that is perpendicular to both of the vectors given. Okay. Here is the formula to find the cross product given two vectors, and notice that since we're in three dimensions, we don't just have I and j, we have I, j, and k. Okay, if you'll copy this formula down, stop the recording, and then I'm going to show you how to actually use determinants to get this so that you won't have to memorize this formula. Okay, here is our first example. Vector u is I minus 2j plus k, and vector v is 3i plus j minus 2k. So if I want to do the cross product, now instead of having to memorize the formula and remember which ones to use, there's an easy way to set this up to show you which numbers to use to do your determinants. Okay, so what I'm going to do is I'm going to write out the components, and remember we have an I, a j, and a k. And if I want to do u cross v, then I'm going to make a row for the components of u. So in front of the I would be 1, negative 2 for j, and 1 for k. And then for v, I would put 3, 1, and negative 2. Okay, now to find the component that goes in front of I. Okay, I'm not going to use the numbers that are in the row with the I. Basically, if I circle the I and cross out the row and the column that it's in, I'm left with 4 numbers. So to find what number goes in front of the I in my cross product, I'm going to do the determinant of negative 2, 1, 1, negative 2. Okay, now in your formula, here's an important part. In front of the second term, it's always a minus. So in front of the j, before I do my determinant, I need to remember to put the minus. Okay, I'm going to cross out the numbers that are in the same row with the j, and I'm going to use what's left, which would be 1, 1, 3, and negative 2. And then I'll do the determinant, and that will be my j component. Okay, and lastly, I'm going to use the k. Okay, so for k, if I get rid of the row and the column that it's in, that means I'm using these first numbers. Okay, and again it's a plus, the only one that's opposite is the j. So 1, negative 2, 3, and 1. So now we do our cross multiplying and our determinants. So for the I, negative 2 times negative 2 would be 4, minus 1 times 1. Then for the j, 1 times negative 2 is negative 2, 3 times 1 is 3, so negative 2 minus 3. Okay. And then for the k, 1 times 1 3 times negative 2 is negative 6. And since I'm subtracting, I could actually write that as 1 plus 6. So now all I have to do is simplify, and I will end up with 3i, negative 5 in front of my j, but it's subtracted, so plus 5j, and then plus 7k. That is the cross product, and that vector would be perpendicular to both of the given vectors. Okay, before you work out this problem, I'd like you to pause the video and try it on your own, and then you can turn it on to see if you've got this concept down. Okay, so if I'm going to do V cross U, when I set up my matrix, I need to put the V in the second column, second row, and the U in the bottom row. So I'd have 2, negative 3, and 1, and then negative 1, 2, and 3. Okay. Now remember to set up your matrices, your determinants. For the I, I'm not going to use the column that the I is in, so I would use the numbers negative 3, 1, 2, and 3 to get the determinant, to find the component for I, minus, the j is always opposite. If I don't use the column that the j is in, the numbers that are left are 2, 1, negative 1, and 3. And then for the k, I would have 2, negative 3, negative 1, and 2. Okay, now remember to do the determinant, cross multiply and subtract. So negative 3 times 3 is negative 9, minus 2 times 1 is 2. Okay, subtract the determinant for j. So when I cross multiply, 2 times 3 is 6, minus negative 1 times 1 is negative 1. And then for the k, 2 times 2 is 4, minus negative 1 times negative 3 is 3. Okay, so when I simplify that, I will have negative 11i. Negative 6 minus negative 1 is 7, but because it was the j component, we do the opposite, so minus 7j plus 1k. So the components for my matrix, if I don't write it in I, j, and k form, would be negative 11, negative 7, and 1. If there was anything that you got lost on or anything you weren't sure on, please put a question mark by it and ask the next time we come to class.